if you follow along or do the problems beforehand. But if you can't do that, then feel free to tune in this channel and just watch and listen. Okay, so the last time we decided that today's problem will be spiral matrix. This is a very pretty problem, and for once the description is fairly short. So let's get to it. Sorry, I have a bit of a flu today, so please don't mind sniffling. So it says here that given a m by n matrix, return all elements of the matrix in spiral order. Okay, so it looks like this. First you start from the top left. You go all the way to the end on the top right. You go down, left, and then back up. And then you repeat the process. So right away I'm thinking there's some like a symmetry here, where first you do the spiral matrix for this outer square by doing this, and then next you do the spiral matrix. You sort of do the same process but for the inner square. So there's going to be some symmetry here, and it looks like the process is there's going to be a outer shell 1, 2, 3, 4, and then an inner shell. That's how I'm going to look at it. Okay, so this is what happens when the matrix is lopsided. Okay, this is what happens when matrix is lopsided. There are a few special cases here that I'm thinking of right away. So what if the matrix is only of height 2? What if it's of height 2? Then what happens? So you'll go here and then come back. Okay. What about width 2? So width 2 looks like it's going to go here, down, and then back up. Okay, this makes sense. And then width 1 is going to go like, height 1 is just going to go like this. And width 1. So I'm just thinking about all the others, the special cases that might happen. I think this one just goes down. So I'm thinking of all the special cases that might happen for this spiral matrix first. Okay. So I think the strategy, the algorithm is going to go like this. For a matrix of size m times n, do the top row. This will be let me see. So m times n, right? So it's this one. So it's going to be 0, 1, all the way to... So we have to be careful here. This is actually... this number here, this guy over here, is actually 0, 4. It's not... Oh, sorry. It is 0, 3. It's not 3, 0. So this is a little bit tricky. It's not 3 0, it's 0 3. Why do I say this? Because when I look at this thing over here, it's 0, which is this, and then 3, which is this. So it's 0 3. It's a little bit weird. It's actually backwards. It unwraps the first outermost layer of the matrix first, which is the which row is in. So it's 0 1 all the way to 0, let's say okay, and then we do this one. So we do down. So step 1 is I can actually color code this. Blue, red, let's say orange, and then let's say green. So blue, red, so red, look at this red arrow here. So this is M and this is N. Then this will be so this is 0, this right here, this is 0M. So this guy, this number 4 here is 0M, and it goes all the way to NM. And then next we do orange, which is NM all the way to 0 1. And finally we do green, which is N 0. So these actually have off by 1 errors. If you think about it carefully, obviously if you do NM in this phase, then there's no need to do NM here. So there are these subtle, well, not that subtle, off by 1 errors, but we're gonna deal with them all the way back to so this is not 0 1. This is not 0 1 at all. This is 0 0. All the way back to 1 0. Okay, and after that you repeat from the matrix, the inner matrix sized you repeat for this matrix. This matrix right here will be M minus 2 because it's got the 2 sides covered, and N minus 2. And you keep doing this. You keep doing this until you're done. Okay. So the tricky part here is this 0 0 changes. Okay, the tricky part is a few things. One, this 0, 0 changes because for matrix m minus 1, m minus 1, m minus 2, the inner matrix, 0, 0 is this guy right here. Is this number 6 here? This is the new 0, 0. So this number 6 has to be the new 0, 0. So when you repeat this, this has to happen. Okay. So let me get rid of this. Okay, cool. Excuse me for the cough today. Alright. Alright. Now let's get going. Let's start coding. Okay, so let's start by doing the first 4 steps first, and then we'll figure this out later. Okay, so the first 4 steps is, given a matrix okay, first we have to figure out the width and the height. So the height is the number of rows in the matrix. So this guy is of height 3 because there are 3 things in it. 1, 2, and 3. And each of these things, each of these rows are of size 4. So this is just length of matrix. And this is length of matrix 0. We're going to make assumptions that the matrix is of at least size 1. M and N must be at least size 1. So if it's not at least size 1, then things break down very quickly. So I from 1 to width. We're going to collect the output somewhere, so we'll say result. So this is a very common pattern. If we want a certain output, we'll just declare a variable that starts empty and then start collecting it. So we say result.append matrix 0 I. Okay, and now red for I in range. So this is a little bit careful here. We have to be a little bit careful here. It does not actually start from 0. It starts from 1. Actually, I should do width minus 1. So this way it starts from 0. So why this width minus 1 is because I want this number 4 to go into red. I want to print 4 in the red face, not in the blue face. And this just gives me a little bit more symmetry. So I'm gonna make my I'm gonna make these arrows a little bit more precise. I'm gonna do it like this. So blue will be here. Oh no. What happened to my blue? So blue, let's say blue here. Blue will be here to here. Red will be here to here. And orange will be here to here. And the last one is green. Will be here to here. So we get a little bit more symmetry here, where we are always going all the way till the second last position. So we're taking the whole row except for the last square. That's why it's width minus 1. So same thing here is height minus 1. Append matrix, and it's gonna start here, right? So this is actually 0 width minus 1, which is the last square here, and I. So we can now copy this for orange. So this is a little bit different. So we have to do something slightly different here. We have to start from width minus 1. We'll go all the way down to 0. And we're going to go backwards. We're going to go backwards. So this range is going to be backwards. And finally, green. So green will be N0. Or we're gonna go backwards here. Oh, I think I'm doing something wrong here. This should be I. Doing something wrong here. Width minus 1. Okay. Cool. So the first number is height. This first number is height minus 1 with I. This is I, and this is, the first number is height. This should be 0. Okay. Okay, I think this is right. I want to take this for a test run. So obviously this will not give us the right answer, but I just want to run it and give me a preliminary sense of what's going on. Okay, so let's go back to let's go to maybe this one. So this is the one, case 2 is the one here, right? Let's see what we've got. The output is supposed to be 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 9, 5. So we 1, 2, 3, 4, 8, 12, 11, 10, 12, 11, 10, 1, 5. So this is wrong. which means our red, blue are correct, but orange and green are wrong. So let's see what's happening on orange. So orange, so this is blue. This is red. So red and blue are correct. Orange, I'm pretty sure is doing this. 12, 11, 10. Oh, so orange is right. Orange is right. It's green that's wrong. Oh, green is completely wrong. Green is 1, 5. So let's see what's going on with green. Orange is like this. Green, oh. Green is very wrong. It's supposed to go backwards. Let's run again. Okay, perfect. Now it looks right. You see, the front part is correct, so the outer shell is correct. We just need to deal with what's inside. So same thing for here. The outer shell is correct. So this is, I don't want to erase this. This is all my precious cargo. But is this like 3x3 spiral here? So this is right. We just need to deal with the purple now. Perfect. And as I said it, I raised my own precious cargo. Okay. Before we proceed, I'm already noticing a few edge cases. So one, actually I'm not sure if I have to check this. One, what happens when width is 2? Or what happens when height is 2? When height is 2. It's a width 4 and height 2 matrix. So in this case, we want to do this is fine actually. This is fine. So we'll still blue. We'll do all blue will be all the way to here. And then red will be 1. This will be go back, and this will be like just this 1. Okay. What if it is a width 1 matrix? So we want to do it here and then down. And I think if we do range height minus 1. Okay, so width minus 1, width is yeah, I think these two will not trigger at all. I think this is correct. Okay, cool. Okay. Now, we're going to repeat for the purple inner matrix. So the idea is the same. We're going to pretend that we're going to start from scratch again. We're going to pretend for the purple matrix, like this inner one, we're going to pretend that we're starting again on a 2x1 matrix. What that means is we'll still have these 4 steps: blue, red, green, orange, green. But there are 2 differences. One, the width and height are changed, obviously, because it's smaller. But the other one is, it is not, the top left hand corner is not 0, 0, it's actually 1, 1. So we have to, which means that we have to change all these offsets. Oops, sorry. We'll change all these offsets. It shouldn't start from 0. It should start from 1, 1. So that's what we're going to do. So first, we are going to put this in a for loop. And we're going to say while, let me see what's the right thing here. So we want to keep doing this until either width is smaller or equals to 0. Oh yeah, while width larger than 0 and height larger than 0. If either one of them is 0, then we're done. If either one of these two are 0, then we're done. Okay, so we're gonna do this, and then at the end of this, we're gonna have new width and height. So width minus equals 2, and height minus equals 2. So it's minus equals 2 because we are stripping we're stripping 1 from each side. So height loses top row and bottom row. So it loses 2 rows, and width loses the left and the rightmost columns. So it loses 2 columns. At the same time, we have to deal with the offset. Want to deal with the offset. So the way we're doing this is that we're pretending once we're done with this matrix, we're gonna pretend that we've been working on this matrix all along. We're gonna do this inner matrix, and we're gonna do this inner matrix exactly how we did outer matrix. So if you were to imagine if we have a very large matrix. I know I'm going over this a few times. I just want to make sure everybody gets it. Dear viewer, you probably have already gotten it. And you might be feeling bored, but it's alright. Alright? So in the first round, we do this, this, and this. Right? In the second round, we're going to pretend that this outer matrix does not exist, and we're going to work just on this inner matrix. And we're going to do the exact same thing, which is this, this, and this. And then third round, we work on the next inner matrix. So we're going to get smaller and smaller successive matrices. We're going to keep going until our matrix is of size 1. And then we just do this. And then we're done. So this is pretty much a strategy. And the reason why we need an offset is because every time we start for the inner matrices, we're not starting from 0, 0. We're starting from a different square. So we can say offset plus equals 1. Okay, now let's take this for a spin. I think this should be correct. Oh, oops. Oh, so it's wrong? Let's see where we went wrong. Okay, we didn't do the offsets. We didn't do the 5. What happened? This is funny. Oh, this actually works. Check this out. So this worked. Okay. But case 1 did not. So case 1 we unwrapped. Okay. So width and height are 3. So case 2 works, but case 1 doesn't work. So width and height are 3. They unwrap the pinata. And so width and height are now 1 and 1. So it should still work. Why does it not work? So blue. Oh, interesting. Check out what happens here. Oh, wow. I didn't realize this. So blue doesn't do the last one. Red doesn't do the last one. Oh, interesting. So this completely doesn't work for a matrix of size. This thing we did here doesn't work for a matrix of size 1 by 1. And it's really interesting. I haven't thought about it this way before. So think about it. For I in width minus 1, so let's say your matrix is of, so the bug is that this thing here doesn't work for a matrix of size 1. Exactly 1 by 1. Any other configuration works. Because it says here, I in range width minus 1. So width is 1. Width minus 1 is 0. Range 0, so it does nothing. This does nothing. This is 0, 0. It does nothing. And then this one also does nothing. Interesting. Whereas if it's a size 2, then let me see. If it's a size 2, what happens? If it's a size 2, the first one width minus 1. So width is going to be 1. So width, blue does something. It does this. And then this one does nothing. Height is 1. So this one does this one. Ah, interesting. And then last one also does nothing. So interesting. The way this is written, it seems like what's happening is it doesn't work if the matrix of size 1. So what we're gonna do is we're gonna special case this. It annoys me a little bit, and it makes me feel a little bit dirty. We're gonna put the special case right at the top. So I have, as a general rule, I have a habit of putting special cases right at the top, because that makes it easier to read and discover. So right away you see, hey, here's the special case. Beware of this. If width equals 1 and height equals 1, then results dot append matrix offsets. Actually, technically, let's be technically correct. So it's 0 plus offset. So it's supposed to be 0, 0. We just add the offset everywhere we go. Okay, let's run it. I think this should work. Yeah, it does work. Okay, and let's submit. Run it on more challenging and rigorous test cases. Okay, we're almost there. 697. Okay, so we struggle a little bit on one-dimensional arrays. 697. It goes like 6979. Ah, this is kind of weird. 697. Why does it print 6979? So 697, width is 3, height is 1. Okay. Let me just draw it out. So we have a 3 by 1 array, 6, 9, and 7. You know what? Let's make our own. We don't need their boxes. We can draw our own boxes. Oops. Six, 9, 7. Okay, all right. So let me see. Blue width is going to be 3. Width equals to 3. Height equals to 1. So for blue, width will be 2. And offset is 0. So I plus offset. So this looks right. Height equals to 1. This also looks right. So where's this 9 coming from? This extra 6979. Where's this extra 9 coming from? This is weird. So I don't think it's from this or this. It might be coming from orange. Height minus 1 plus offset. So this is 0. So width is going to be width minus 1, 0, minus 1. Width minus 1. I think what's happening is that okay, I'm pretty sure what we need to do is to say if height is greater than 1, do this. But I'm not sure why it's not taking care of that automatically. This is looking for the last row, right? This is the last row. Okay. Oh, yeah. That makes sense. So I don't think it takes care of that automatically. But what I don't get is why... What I don't get is that why it says 6979. You know, if orange is the one that's printing out the 9, who's printing out the 9? If orange is the one printing out the 9, there's no reason for it to print 9. It should print 79. 6979. Oh, interesting. I think what I got it. I think I know what's happening here. So I can't do this. If I do this, then I won't get the 7. I'll lose the 7. So what's happening here is blue is printing 69. And then orange is printing 79. So if I want 697, this is really annoying. So I know what the problem is. I just need to figure out what's the most elegant way to solve it. There are many good ways. There are many ways to solve it. There are many ways to solve it. The simplest way is actually to special case it, just like I did here. I can say when height equals to 1, then yeah, when height equals to 1, do something special. Okay, you know what? I'm going to do that. So when height equals to 1, I'm going to go all the way to the end. Because when height equals to 1, and then I have to do the same thing for when width equals to 1. If height equals to 1, I'm going to go all the way to the end. So it goes all the way to width. So I want blue to print all 3. And when width equals to 1, I want red to print all 3. Okay. If height equals to 1. So I don't think I'm gonna need this after I add this special case. If height equals to 1, results dot append width plus offset. Okay? So what I'm saying is that I'm going to print these 6, 9, and if height equals to 1, I'm going to print the 7. The reason why I do that is because I'm not going to print, when height equals to 1, the red face doesn't happen. There's no red when height equals to 1. So so might as well print, might as well print 1. Oh, why don't I put this here then? If height greater than 1, if height is greater than 1, then I'll print the last row minus the bottom left corner. If height is exactly 1, I'll just print. Yeah. Okay, let's fix this first and then tidy it up. So the same thing we need to do for the width. When width equals to 1. Okay, so let's pick a different color. We're gonna erase this first. This is oddly satisfying. Erasing? Yeah. Okay. Alright. So when width equals to 1, or rather, let's just pick black. When width equals to 1, blue and orange will not trigger. So I want red to print all 4. And I want green to not do anything. So red will print all 4 when width equals to 1. And this will not trigger if width is greater than 1. Okay, cool. I think this will work. Let me submit again. Oh, none of this works. I'm completely wrong. Look at that. Okay, look at what I printed here. Gosh darn it. What monstrosity have we ended up with? We got 7 instead of 8. I just made it worse, haven't I? Okay. I've just made it worse. Well, I think maybe the easiest way to do this Okay. So what's happening here? Let's try to understand this a little bit. Why is this 8? Why is it going to 8? Who is printing this? 6, 5. Wait, what? Oh, yeah. So it's 6 and 8. Okay, who is printing this? Well, actually, we're not that far off. Okay, who is printing this? Six is printed by this guy, and 8 is printed by this guy, I'm pretty sure. So 6 is printed by this guy. It's not supposed to print 6. It's supposed to print 5. Oh, I see. So it's with -1 plus offset. Is that off by 1 error? So this is height -1 plus offset. And only do this when height is greater than 1. If width and height are both 1, then we'll just let this guy take care of it. Okay, we're gonna run it. I think this should be correct. Look at that. It's correct. Okay. So that's our problem for today. Okay, so I'm going to think about this a little bit more. Let's think about this a little bit more. Is this, is this the most, is this the best way to structure this problem, right? With this height and this, is it the best way to handle this special case? I actually think it's not. I think that we should do this. If height equals to 1, do something. Elif width equals to 1, and then do something. Else, do this thing right here. I think that makes a little bit more sense. It makes a little bit more sense than these special cases. So reason why is because this actually is, technically speaking, mildly faster. It's faster in a completely almost trivial way. But the problem with this is that it's hard to read. Like width equals 1, height equals, whoa, this is kind of hard to read. I'm gonna be honest. So instead, we're going to value simplicity or readability over all else. So if height equals to 1, we are just going to print the row, right? So we're going to basically do blue. Width -1, 0 plus offset, I plus offset. Okay. Except we're not doing width -1, we're just doing width. So if width equals to 1, we're going to do basically red. we're going to do here we're just going to do height instead of height minus 1. Okay, I think this will work. Let's run it. And it makes it much easier too. Aha, great. Now it makes it a little bit easier too. It makes it a little bit easier to read. So we have the 2 special cases at the bottom, and then the general case, which we have the 4 distinct, sections. The runtime should be very similar. I think, it says here it looks like it's a big difference, but I'm pretty sure if I run it a few times, it's going to, it randomly fluctuates. It goes from 35 ms to 46 ms. So in general, these like low ms numbers, these like very quick programs, this doesn't mean anything because you just run it a few times, you get wildly different results. If I run it again, so it goes from 46 to 42, 35, 46, 42, right? Now it beats 29% instead of 9%. Okay. Yeah, I think I like this a little bit better. If height equals to 0, we just handle the 2 special cases up here, and then we do this. All right. So that's it for today's problem. Let's look at the next problem that we can solve for next time. Hit me in the comments with whether you like this problem or you don't like this problem or whatever else you want to talk about. I want a medium one. I think medium sounds about right. The hard ones can be a little bit tricky. Let's look at this. Let's scroll down a little bit. Let's do a lot of scrolling down. Sort list. I don't know if I like this. Given the head of a linked list, return the list after sorting it in ascending order. So this is a very large number of nodes. So the idea is you can't do some kind of quick sort because that's going to take too long. You will need to do some kind of probably some kind of merge sort is my guess. Okay, let's do this one then. Let's do this for next time. Add to lists next. Okay, all right. So problem 148 sort list for next time. I'm going to put in a stream description, and that's it for today. Thank you everybody for watching, and goodbye.